Hello, nerds, and welcome to a rare late night edition of Math with your man, McCutcheon. That's right, I said it. Nerd. Okay. Hopefully, the audio is coming through well. I am kind of talking loud. I'm at home. I don't have my microphone set up from school, but we got to do what we got to do. I have a lot of people that are still struggling with some basic properties of curves. Domain, range, positive, negative, increasing, decreasing, maximums, minimums. I've got on here some asymptotic behavior and some end behavior as well. And I just thought maybe if we had some easier examples, I could have more people be more successful. Okay, so if you want to follow along and just watch, that's fine. Maybe pause and predict answers. I don't know, whatever you want to do. Or if you want to print this thing off of Schoology yourself and keep it as notes, whatever you want to do. Okay, so what do we got going on? First, I've got some generic f of x here, and it has an endpoint here and an open dot there. Okay, endpoint means that this point actually exists and is the ending. Open dot means this is where the graph is going to come to an end, but this one coordinate in space simply doesn't exist. All right, get right into it. Domain and range. Now, the domain is all of the x values that this graph can cover up. Or you could think of it as, imagine you're taking a walk down this x-axis. You're chilling, you're walking, and if any point in time you can stop and look up or look down and see your graph, then you are on an x value that is part of the domain. Okay? So you start your walk from the far left, and as you head to the right, you look for the very first time that you could look up or down and see your graph, and I'm hoping you can see that that would have occurred right there. This x value at -7, you could look down and see that your graph exists. And since it is a dot, I've never used this pen before. True, very first time. This is a special video. This is a teal pen. I wonder what this is going to look like. I'm excited. Anyway, you could stop right here at -7 and look down and see this dot actually exists, which means it is a bracket at -7. It's kind of anticlimactic. It just kind of looks blue on the camera. Oh, well, whatever. So we start our viewing of this curve either above us or below us right here at this number. And as you walk to the right, still below you, still below you, still below you. Boop, all right, now it's above you, above you, above you. And you talk about all the x values where this thing is above you until you can't see the curve anymore right there at 9. Here's the problem, though. The graph doesn't exist at x equals 9 because that dot is open, so we get parentheses there. All right. Range. It's the same kind of idea. Domain was you took a walk on the x-axis, looked up or down, and looked for your curve. Range is imagine you're climbing the y-axis like a ladder. And as you're climbing from the bottom up, because small numbers to big numbers, as you're climbing up, if you can look left or right and see your curve, then you are at a number that exists on the range. Right here at this point, to your left is your curve. This is the lowest y value that exists for your graph, and it is a closed dot, so it exists. Remember what we're doing. We're climbing the ladder until we were to look left and right and no longer see our curve. So we're climbing up, curves to our left, 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 whoop, all right, to our right, to our right, to our right. And here's the thing. I know that there's a hole in the graph here, but this is not causing me a problem on the range because if I'm right here on this ladder rung and I look to the right, there's my curve still. So this graph does exist at y equals 6. You know where it stops existing? Right here at y equals 8. And this is a part of the curve, so y equals 8 is the top of the range and is included. There. Now, positive or negative has to do with whether or not the y values are positive or negative. Now, this is the only interval where you talk about the actual y values. Every other interval, domain, positive, negative, increasing, decreasing, these are all x values, and they're x values where something is occurring. So if we are here, we are wondering, what's wrong with me? Oh, okay, sorry. I had lost my train of thought for a second. Positive and negative has to do with whether or not the y value was positive or negative. So we said our domain began over here. So you're looking over here, and you're noticing that you have to look down to see your curve. Well, down here, all your y values are negative. So your domain is going to begin with negative y values. So our negative values begin at x equals negative 7. And let's see when the y values stop being negative. Right there. Ooh. Right there, my y value is 0. And 0 is not a negative number. So right here at x equals negative 3 is where my negative y values come to an end. And since the y value here is 0, which is neither positive nor negative, you put a parenthesis on there. And here's what's up. If this is the only part of your graph that exists below the x-axis, then all of the rest of the domain, which means from negative 3 to 9, is where you have positive y values. And all of these numbers here have positive y values. So our positive zone begins at x equals negative 3 and comes to an end when the domain comes to an end, and that's at 9. But remember, 9 does not exist. X equals 9 does not exist. So positive or negative just has to do with whether or not you're above or below. Think of this as being like, I don't know, the surface of the ocean. You're either underwater or above water, okay? If that helps. I don't know, some people that helps. How about increasing, decreasing? This is the roller coaster. Remember, we read all of our graphs from left to right. So the question is, if you were chilling right here on this track, there's you chilling on the track, okay? At the beginning of this domain, your roller coaster would have to be going up, which is increasing. And since this point is the beginning of the domain and exists, we're going to put a bracket on it. Negative 7. So beginning at x equals negative 7. You know, that's the roller coaster car going up, and it goes click, 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 click. You are increasing until you go whee! And the question becomes, at what x value do you scream whee? Well, I'm hoping you're seeing that right here is where your roller coaster hits the top, and then it would stop clicking, and you go whee! Okay? That means this is the x value at x equals 5, where you stop increasing. And College Board, the people who write the AP exams, say that we put brackets on the x values where we change between increasing and decreasing. That means we start decreasing at that x equals 5, because that's where you start having all the fun and shouting "we." And you are decreasing until the domain ends. And the domain ends at 9. And since 9 doesn't exist, it cannot be a bracket. Those are all of the intervals for this graph. Now let's talk about maximums and minimums. Changing between increasing and decreasing is always going to happen at a maximum or a minimum. Notice that this 5 is on both of these intervals. That's because this point right here, let me use a color you can see. This point right here, we call it, well, that's supposed to be green. It didn't look very well in the video, or it didn't come up very well in the video. But anyway, that's green. That point right there is a place where we stop increasing, start decreasing, and locally it is the highest point. So we would call this a maximum at 5, 8. This is a coordinate, not an interval. This is an x, y. This is not a span of x values. It's literally this point in space. And minimums would be like, you know, the bottom of a valley. Now, we don't have any bottoms of valleys here, but you know what we do have? We do have a lowest point at this end point. And because this is a closed dot and it is the locally lowest point there, it is a minimum by definition. So -7, -10. Again, this is a coordinate, not an interval. So yes, endpoints can count as maximums and minimums, and because this dot does not exist, it cannot be a maximum or a minimum. If it was closed, it would be a local minimum because it would be the lowest thing in its general vicinity. Okay? I hope that that clears up domain, range, positive, negative, increasing, decreasing, and extrema. Let's move on to boop, this simple graph right here. I would like you to see that right here, this graph is getting remarkably vertical. And that's not an accident. It actually will approach this vertical line right here, but will never reach it. This vertical line happens to be a vertical asymptote. Over here, is it starting to flatten out? Well, it might look like that, but remember what an arrow tells us. The arrow tells us that the behavior that we're viewing doesn't ever stop. And since this didn't overtly, obviously approach a horizontal line, we cannot assume that it's becoming horizontal. So it's just going up and to the right forever, which is going to allow me to write the end behavior of this side. And see, as we're going that way, my x values are getting bigger. So we say, as x approaches the far right, and we write that as positive infinity. So as we're going out here, the y values are going to, well, it's up and to the right. You know what's up? Positive infinity. It almost sounds like one of those what's up dog jokes. You know what's up? Positive infinity. I think I'm going to say that next time somebody asks me what's up, I'm going to say positive infinity. In fact, I hope it happens tomorrow. Anywho, that's it for the right side in behavior. Now the left in behavior, why did I put it in quotations? Because the left side of this graph is actually asymptotic. It's approaching a vertical asymptote. Remember, when we approach a vertical asymptote, we have to say which side of the asymptote we're approaching from, because oftentimes if a graph exists on both sides, this one doesn't, but if a graph exists on both sides, you're usually going to have different behavior on the two sides. So because of that, when we list our asymptotic behavior, and I'll write it in red since the asymptote is red, because of that, we have to say which side of the x value that we're on. So we're going to say as x approaches the number -3, so I'm approaching this value, so I'm over here and I'm heading this way. I'm heading this way, I'm heading this way, I'm heading this way, and I'm getting closer to this number, but I'm always to the right of it. Just a hair to the right. And that little plus sign tells us just a hair to the right. So as x is getting close to -3, but you're always just a little bit to the right of -3, what are your y values doing? Well, if you were taking a trip on this curve, and we always go from left to right, but let's just, for the sake of argument, say you were heading this way. As you were taking a trip on this curve, the closer you got to -3, the further down you start to shoot. And you know what's down? The opposite of what's up. Negative infinity. So there it is. The y values are heading down to negative infinity as I get close to x equals -3 on the right side. Alrighty, that's it for that graph. And the last one for this nice quick video is literally just in behavior. Now I've got you a graph here that's got some strange asymptotic behavior, but it does obviously get vertical. I mean, will it ever actually be 100% vertical? No. But it's like it wants to be, right? It's trying to get to that line at x equals -1. It's trying to. This is shooting off up and to the right. This is shooting left and down. So we can actually describe both endings doing in behavior. And, you know, I can't get enough of this teal color. On my end, on the paper, it looks gorgeous. So let's start on the left side. Let's talk about this end right here. As we go to the far left, so as x approaches the far left, which is negative infinity, let's talk about what our y values are doing. Well, this behavior never stops. Looks to me like I'm sinking, and I'm off the grid. And not only is it off the grid, it was off the camera too. But the point is, it's going down. That's where y is finding negative infinity. Now let's head to the right. Whee! Out there. As x heads towards the far right, and you know what's way out there? Positive infinity. Our y values, well, looks like they're going up to me. You know what's up? Infinity. I think that's my new saying. You know what's up? Infinity. Those who know, they know. We'll get some chuckles. And lastly for this video, the behavior at the asymptote. You see this graph is approaching the number x equals -1 from two different sides, and it has different behavior on opposite sides. So let's do the left side first. As x approaches the number -1, but on the left side of -1, little minus sign means to the left of -1, so you'll never quite get there, but you'll always try. Your y values are heading towards down, negative infinity. That's right there. As I go towards this thing, I crash down. Now over here, as the graph heads towards x equals -1, but I'm on the right side. Now I'm over here. The closer I get to -1, but just a hair to the right, that's what that means. Your y values are going up, and they're getting there fast. You know what's up? Infinity. And that is it for this short video. I hope that somebody finds it beneficial, and hopefully we can crush the upcoming tests. Anyway, nerds, I appreciate all the effort every single day, and I look forward to seeing you in class mañana. Deuces.